Dear students, welcome to the operating system video lecture sessions. In the previous lecture video, we have discussed about CPU scheduling, FCFS scheduling algorithm. In this lecture video, we are going to discuss about the other scheduling algorithms. So in the last video, we have discussed about basic concepts and scheduling criteria. And one of the scheduling algorithm we have completed, that is FCFS. And the objective, which was very clear, we are going to introduce CPU scheduling, which is basis for multi-programmed operating system, which we are using now. To describe various CPU scheduling algorithm, and among one scheduling algorithm we have completed. And after this, we are going to discuss about evaluation criteria for selecting CPU scheduling algorithm for a particular system. So in this lecture video, by the end of this lecture video, you will be able to define and apply SJF, shortest job first algorithm, to find or to calculate the average waiting time for the given processes. So in the last class, we have discussed about FCFS scheduling algorithm. In that, the input is different process and burst time will be given. So according to the first whichever the process is come, that will be served first. So this problem we have discussed. So first process will take 24 units of time, and second 3 units and 3 units. So by this, we got the average waiting time as 70. The average waiting time we got AW2 is 17. So these are the individual waiting times. So this is FCFS. With the FCFS, we got this. Okay, the problem here is in the given three process 1 actually it is taking 24 units of time. Process 2 is taking 3 units of time. Process 3 is taking 3 units of time. But comparing to P1 and P2, P2 is having very short burst time. It requires very short burst time comparing to P1. So because of this P1, it is waiting for much time. This is the problem with this FCFS. So if the process is in this order, P2, P3, P1, that means if you take this small job, that is shortest burst time is first, then this will be your Gantt chart. So it is 3 units of time, then 3 units of time, then it is 24 units of time, right? So for that, if we calculate the waiting time and average waiting time, this is average waiting time is 3. Just see the difference here. When you are using FCFS, it is taking 17 units of units of time. But now when you are considering the shortest burst time, if you are considering first, then it has reduced to 17 to 3 units of time. So this is much better than the previous case. So whenever a shortest job is waiting to accomplish this longest job, then the shortest job is waiting for long time. So such a kind of effect, we call it as convoy effect. We call it as convoy effect. So the shortest process behind long process. So this is just like this. So if you are in a way and you are driving your car, but in front of you, if there is a very big truck is there, for example, there is a very big truck which is holding the cars and it is occupied all the entire road, then what will be happen? Even though you are having enough speed, you are having enough petrol, enough gasoline, but due to this longer job, you are not able to go complete it fast. So that is the problem. So this such a kind of problem, we call it as convoy effect. If process 3 is process 2 needs very short bus time, process 3 needs short bus time, but these two are waiting to complete this P1. So such a kind of situations we call it as convoy effect. So in order to overcome that, we are going for the shortest job first scheduling algorithm. So this shortest job first scheduling algorithm associate with each process length of its next CPU burst. And it uses the length to schedule the process with shortest time. Whichever the process is having shortest time, then that will be given first priority. And SJF is optimal, gives minimum average time comparing to the FCFS. But the drawback of this SJF is it is difficult to know the length of the next CPU request. So this is always, it's a problematic here. So this is the drawback. Okay, anyhow, we will discuss about this drawback after completion of few examples. Let me go with an example. So these are the process and burst time given to us 6873. Let us solve this. 6873, that is process 1, process 2, process 3 and process 4. There are 4 processes. These are the processes and this is burst time. Now we have to calculate the average waiting time. Our ultimate aim is to calculate the average waiting time. So to calculate the average waiting time, we have to calculate the individual waiting time. So before calculating the individual waiting time, we have to draw the Gantt chart. Okay, this is the Gantt chart. So Gantt chart will start from 0. As it is shortest job first, so obviously 3 is having the shortest job. So 3 will come, P4 will come first. So P4 is having the shortest job. So it starts from 0 and it ends with 3, right? So after that, the shortest job is, obviously it is P1. So take P1 as the next process and its burst time is 6. So 3 plus 6, it is 9, right? After that, we are having shortest job is P3. So consider P3 and 9 plus 7, it is 16. Then the longest job is 8 units of time. So consider this P2 here. 16 plus 8 is equals to 24. So this is your Gantt chart, right? Gantt chart, we will draw time against the different processes, right? Okay, now calculate the waiting time for each and every process, waiting time. So waiting time is for the P1. What is the waiting time? What is the P1 waiting time? P1 has waited till the 3 units of time. So waiting time for P1 is 3. Coming to P2, it has waited up to 16 units of time. P2 is having 16 units of time. P3 is having waiting time as 9 units of time. P4, it started with P4 only. So it has not waited for any time. So its waiting time is 0. Now calculate average waiting time. Average waiting time is equals to P1 plus P2 plus P3 plus P4 by 4. So 3 plus 16 plus 9 plus 0 by 4. 19 plus 9 is equals to 28 by 4, that is 6 point, okay, 4 sevens are 28, so it is 7 units of time, 7 units of time. So the average waiting time is 7. Now let us check with this one, right? See, this is 6873, the given burst times, and this is the scheduling chart, that is the Gantt chart. We can also call it as Gantt chart. So starting with P4, then P1, then P3, P2, and average waiting time for this is 7. So in this way, you are going to calculate average waiting time by using shortest job first. But the problem with this is determining the length of next CPU. How can we know that this is the shortest job? So for that, again, it's a problem to find out what is the shortest job. So we can only estimate the length, and that should be similar to the previous one, that is SJF one. Then what you are going to do is then pick process with shortest predicted next CPU bus. So here you are going to predict. So this might be the shortest one that you are going to predict. So that can be done by using the length of previous CPU burst. Previous CPU burst by using an exponential averaging. So how you are going to do that? So this is what your formula. So tau n minus 1 is equals to alpha tn plus 1 minus alpha tau n. So here the tn is equals to actual length of nth CPU burst, tau n plus 1 is equal to predicted value for the next CPU burst, and alpha is generally it is between 0 to 1. Generally we will generalize to half. So this kind of version we call it as shortest remaining time first. So shortest job first will become shortest remaining time first. So when you are taking this shortest remaining time first, so this is the process. If for this preemptive, it will be having the arrival time. So this arrival time is going to tell you the process when it has arrived, the time will be given with us, right? So these are the process which is tied with its arrival time. So first process entered is 0, second process is entered is 1, 2, 3, right? So its burst time, corresponding burst times are 8, 4, 9, 5. Now let us draw a Gantt chart for this, right? So we'll try to do this 8, 4, 9, 5. 8, 4, 9, 5, 0, 1, 2, 3, process 1, process 2, process 3, process 4. So this is the process, this is arrival time, and this is burst time. Now calculate the shortest remaining job first, right? So for this, draw the Gantt chart again. For all the things you have to draw the Gantt chart. So Gantt chart generally starts with 0. Okay. At 0th time, process 1 has entered and its maximum time it is utilizing 8 units of time it need, right? But this is shortest remaining job first. Shortest remaining job means what is the next job which is having less than this one. So when you entered into 0, 1, 2, 3, when it enters into the timeline 1, process 2 has entered. So process 2 has entered, at the same time it is having the shortest remaining time. So what is the shortest remaining time? Its shortest remaining time is 4. So already 1 is completed. 1 unit of time is completed. 1 plus 4 is equals to 5. So process 2 is completed. Then by the 5th unit of time, process 2 and process 3 are already there, right? So comparing to these two, 5 is having shortest remaining time. So P4 will be entered, and 5 plus 5, it is 10 units of time. Then the next one is 9, but the shortest remaining time it is 9, and it is having only 7 units of time. It requires 7 units of time. Why? Because 1 is already completed, so it is 7 units of time. So P1 will again enter here. So 10 plus 7, it is 17. Then the last one is P3. P3 is only 1 remaining. So 17 plus 9, it is 26. So this is your Gantt chart. Now calculate the waiting time for individual one by one process. Waiting time for process 1. So process 1 waiting time here, process 1 comes first. So its waiting time is 0. Again, is there process 1 again here? Yes, it is. So it is how much time it has waited? 10 units of time it has waited. But among this 10 units of time, it is already utilized this 1 unit of time. So this cannot be, in this particular unit of time, P1 has not waited for the CPU. So minus 1, right? This is process 1. Okay, so process 1 waiting time is 9. Then process 2. So process 2, how much time it has waited? 1 unit of time. But when it has arrived at that time itself. So 1 minus 1 is equals to 0. Coming to P3, process 3 waiting time is, so process 3 arrived at 17 units of time on the Gantt chart, but when it has arrived, process 3 has arrived at 2 units of time. So you have to remove 2 from 17. So it is 15. Process 4. P4 has entered at the time 5 units of time. So it has waited for 5 units of time. But P4 has entered at the time of 3 units of time. So 5 minus 3 is equals to 2. Now you got all the individual waiting times. Now calculate the average waiting time. Average waiting time. So average waiting time is equals to 9 plus 0 plus 15 plus 2 by 4. That is 9 plus 5, it is 24 plus 2, 26. 26 by 4, that is 4, 6 are 24, so 6 point something. You will get answer is 6 point. Average waiting time is 6. Now let us see 6.5. So these are the calculations. This is individual waiting times, 10 minus 1, 1 minus 1, 17 minus 1, 15 minus 1. So this is your average waiting time. So this is all about shortest remaining time first. So with this, we have completed shortest job first. In the next video, we will see about next scheduling algorithm, that is priority scheduling algorithm.